The Neanderthals were a group of humans that lived from around 400,000 to 30,000 years ago and are our closest ancient relatives. Some argue that they are a subspecies of Homo sapiens, although most scientists would still consider them as separate. All ancient human species originate from Africa. However, Neanderthal ancestors began to migrate away via the Middle East. Contrary to what we'd like to imagine, this was no great expedition. They were moving very slowly, around 1 kilometre per year, probably just searching for fresher land once they'd exhausted the previous. They eventually colonised most of Central and Eastern Asia, reaching as far as the Altai Mountains and Siberia. Here, a group of Neanderthal-like humans known as the Denisovans were also evolving, our other closest ancient relatives. Neanderthals colonised much of Europe as well, from Croatia to Portugal and everywhere in between. When the Neanderthals reached what is now Britain, the ice would have extended as far as just south of Manchester. Here they would have lived among woolly mammoths and rhino, finding shelter from the cold in caves. An example of a Neanderthal settlement can be found in Derbyshire in the limestone gorge of Cresswell Crags. Here, there is evidence of Neanderthal occupation from around 55,000 years ago, and findings from these caves have been tremendously important in understanding the behaviour of Neanderthals. But first, what did the Neanderthals look like?
They are similar but different from modern human beings in that they have a slightly different body shape, a different morphology. So if you compare the skulls, for instance, Neanderthals have what's sometimes described as a rugby football shaped skull. There are also differences, for instance, in the shape of body. Neanderthals are often described as having been barrel-chested, their arms legs are somewhat shorter. The shape of their faces, for instance, they would have had, we know from looking at the skulls, quite thick brows, a very strong but receding chin, also quite a long and flattened nose. And their gait was often described as shambling and stooping. So some of the first interpretation of Neanderthals actually are very misleading.
Early interpretations of Neanderthals pinned them as aggressive and unintelligent cavemen, as shambling brutes far less able than modern humans today. Over the last few decades, both archaeologists and evolutionary biologists have been breaking down this negative image, instead suggesting they were much more like ourselves than we originally thought.
We now know that Neanderthals were really capable and would make fantastically skillful stone tools using materials like this flint. Skilled flint knappers strike this in sequence to create a tool for the purpose they intend. Creating sophisticated stone tools is actually a very complex process. Using a simple pebble that we call a hammerstone, you have to chip this flint in the right place, in the right order. You have to imagine where to strike before you take any pieces away. A combination of planning, sequencing, and manual dexterity. It shows that these Neanderthals really knew what they were doing. Far from crude, this tool with all of these textures gives you a really good grip. So here it is, the best Neanderthal multi-tool.
By attaching these tools to wood using animal intestines, the Neanderthals would make spears to hunt with. They'd also use these tools for chopping and to make fire, generating a spark by scraping metal along the flint. For many years, these tools remained the staple characteristic of a Neanderthal, and so too did the image of the aggressive and combative hunter. But we now know there's much more to them than just this. Recent archaeological evidence has shown that the Neanderthals would have worn jewellery made from teeth and bone, decorated their bodies with feathers, and made art.
In some sites, dishes made from scallop shells were used as paint as palettes, red ochre inside. Neanderthals doing their first dabblings in creating abstract art.
Neanderthals were also much more caring than we'd given them credit for. There is some evidence to suggest that they looked after the elderly and weak, and even gave ceremonial burials to the dead, making graves adorned with flowers. All of this points towards the Neanderthals being capable of symbolic thought, a characteristic often regarded as unique to our species. So how similar are we? Most of what we've covered so far has been based on archaeological finds, but following the turn of the century and the introduction of genetic analysis to the field, there has been a few surprising revelations about the role of Neanderthals in our own evolution. In 2010, the first draft of the full Neanderthal genome was described, and by comparing this to the DNA of modern human populations, scientists found that the two species actually interbred. Whilst the Neanderthals were existing in Eurasia, Homo sapiens were continuing to evolve on the continent of Africa. Around 40 to 50,000 years ago, they too migrated away and crossed paths with the Neanderthals. There's evidence of these interbreeding events in the DNA of all modern humans today. In fact, it's estimated that in Europeans, at least 1 to 2% of your DNA is Neanderthal DNA, and this is slightly more in people of Asian descent who also have some DNA from the Denisovans. So what genes did they give us? The research is all relatively new and relies on complex computer modelling to give us the answers. However, there are 3 main categories of genes so far that we can confidently say were influenced by the Neanderthals. Firstly, genes associated with skin, eye and hair colour. The genetic control over pigmentation is incredibly complex. However, a few genes have been linked to our Neanderthal ancestry. It's difficult to tell exactly which, if any, pigmentation patterns may have been promoted, but the frequency of Neanderthal DNA in these areas of the genome do suggest some sort of importance for adaptation. Secondly, there are genes associated with immunity. If you're someone who suffers from allergies, then you may have the Neanderthals to thank, since the archaic variations of these genes contribute to a heightened immune response. When Homo sapiens met the Neanderthals in these new environments, it's likely they encountered new pathogens, and so an exchange in genes that respond to these infections would have been useful. Bizarrely, some of our Neanderthal DNA is associated with diseases like diabetes. Why would modern humans carry with them a gene that's harmful? Perhaps it's because several thousand years ago the gene had some sort of benefit, but as environments quickly changed, it no longer fit its purpose. For example, the Neanderthal version of a key gene for lipid metabolism promotes fat storage. Hundreds of thousands of years ago, when they lived in glacial periods and food was scarce, it would have been useful to store fat. Now, this isn't so helpful. So the Neanderthals might not have been so different from us after all. If there's anything to learn from this, it's that the story of our evolution is far from linear, and the Neanderthals are just one part of it. Many other Homo species have walked the earth, living and interbreeding at the same time until it was just us left. Human evolution was messy and convoluted. New research is published every week, rewriting our story with fascinating twists and turns. But as these extinct hominins live on in our DNA, we can thank them for the genetic gifts that surely helped us continue to survive.